Give me a second. You are live. I should be live. Let's wait until I can see it here. Looks like there is something wrong with my OBS. Oh yes, great. You can see me. I will also check my sound. Give me a second. Great. So, hello everyone on my first live stream. This is a form of an experiment. Hopefully the next time I'm conducting it, I will know this tool better. I will be better prepared for using YouTube and these live features. I would like to quickly introduce you to the formula. This is a live Q&A, meaning that I am mainly for your questions. You can ask them on chat and I will try to answer all of them. But before questions, I will give you time to ask them and give you a small lecture. Today's topic is what is a coroutine. So we'll surely talk a bit about Kotlin, but I would like to start the story a little bit earlier than in Kotlin. Many years before Kotlin was created, coroutines already existed and already were quite important. When I ask people what is a coroutine, people often say it's a lightweight or a virtual thread. Well, this is not true. This is not true at all. Coroutines are way older than parallelism in our computers and way more general than the idea of virtual threads. I will address pretty soon again. 1 second before I start, I have a short announcement. I've been working on the new version of Kotlin Coroutines, the 2nd edition, and it is live and ready on Amazon already. It's been a year since the previous edition. It's not that a lot has changed in the library, just the opposite. Nearly nothing has changed, and I didn't need to update this book nearly at all. Only a few minor changes. I added a part about Loom in the dispatchers section. I added things like a background scope in the testing coroutines section, but the biggest difference is that I added a whole new part. So it has the 4th part, which is about the best practices and common use cases, and I also added a nice section about testing flow. I have a much more experience with testing flow right now, so I wanted to share some useful tips and tricks. I also would like to say that this new version of Kotlin Coroutines perfectly fit the functional Kotlin and Kotlin essentials on the bookshelf. So that's a bonus from my side. If you collect them all, you can make a nice. They can form a nice shape. It's still the beginning. I have other books in my mind to continue that as well. Okay, so getting back to the concept of coroutine. Coroutine, by definition, is a you can say it's a part of code that can be suspended, a component that allow suspension and resuming. This is a pretty nice definition, which we will use. And the oldest implementation of coroutines that I know comes from Lisp. The Lisp or Scheme. There was a library called CL coroutine that allowed you to define a coroutine. Here you have an example. You define a coroutine, which is a form of a function, a function in which you can yield. You know, coroutine means you can suspend and resume. Yield suspends this function execution. So when you start this function execution, it will execute until the first yield. Yeah? Then this function execution suspends, but you can always resume it with what function was that? Call function coroutine. Okay, just fun call. So you can see you call this. You create a coroutine object. You call it with a value Smith. This value is passed to whom, and so when you take a look at what's printed, you can see first greeting to Smith. Then the coroutine is suspended. When you call it again, but this time with another value Johnson, the second part, the second line of this coroutine, second greeting to, is executed with the value whom. You see, this way, not only this way our execution jumps between this function and this top-level execution. What is pretty powerful? Back then, there were no multi-core processors. All processors were single-core, so it was quite hard to speak about parallelism. So actual execution of two processes at the same time on a single computer. We could only talk about concurrency, meaning doing a bit of that, a bit of that, a bit of that, a bit of that. Of course, the term concurrency also includes parallelism, but in this case, we mean jumping between different processes. And coroutines allow that. It's very important. It's not only very important, it's essential, because this is what we do in Kotlin Coroutines on Android pretty often. Many applications primarily or only use dispatcher's main, so they only use a single thread, the main thread, but they use it concurrently, so they execute multiple processes interchangeably. If you take a look at this implementation of a coroutine, it might remind you another popular language which also has a form of coroutines. I'm talking about Python. What we just have seen is very similar to Python sequence generators. Yeah? So Python sequence generator is here is a Python sequence generator, is a function with yield inside. And it is a form of a coroutine. Why it is a coroutine? Because the execution of this function can be suspended and resumed. So I prepared this small code example for you. Here we define a function cube, which yields next numbers. Notice that I can ask for a generator and ask for the next values. And everything in here is executed on a single thread. I mean, in general, most things on Kotlin, on Python programs are executed on a single thread. It's possible to use multiple threads on Python, but Python is, generally speaking, single-threaded, and yet it is using those generators pretty intensively for concurrency, for doing a bit of that, a bit of that, a bit of that, a bit of that. So if you take a look at my example, you can see that when I execute this code, I first print A and then I jump inside this function and I execute it until the first yield. When I have the first value, I print this first value, okay, and then I print B. So you can see our program execution jumps between this top level and this function. So it's like I execute here, but when I call next, I'm jumping inside this function until the first yield. Then I return the value, I print b, and then when I ask for the next value, I jump into the place where I suspended, so into this yield. Then I can iterate over the rest of those values and use my generator until the end. So this is a form of a coroutine because this function can be suspended. It is suspended at the yield point. Also notice that what you can see in here, this form of a coroutine, it's not really working with Project Loom's virtual threads, you know. It's not that you could, I mean, technically speaking, you could implement something similar using virtual threads, but it wouldn't be the same, you know. The point is that you are executing everything here on a single thread, not on multiple virtual threads that are you know, communicating with each other in some way using some synchronized tools. The point is that we are literally executing everything on a single thread, and we can jump in the middle of the function and execute from where we stopped. This is the essential trait of a coroutine. Of course, this can be implemented in Kotlin using sequence builders. Sequence builders are also using suspend functions, yeah, and they also use a coroutine. But sequence builders, by their nature, are like Python generators. When you execute this sequence, you are doing that on the same thread. You know, you are not changing a thread in any way. You are just executing you're just continuing execution. Nothing is suspending. You're just continuing this execution. So when you're asking for the next value, you jump inside this lambda expression. You execute until the first yield, then the value. Then you execute this for each lambda expression. Once it is done, you are jumping into where you suspended, and you resume from there until the next yield. Yeah. So everything is executed on a single thread. What is quite important to understand that coroutine does not mean operating on multiple threads. You can operate on one thread, and it is perfectly reasonable. However, I believe the most important nowadays form of a coroutine, which is present in many languages, but my favorite one is JavaScript, except for Kotlin, of course. And I'm talking about async await. Async await is, of course, a form of a coroutine as well. When you define an async function, this function, when you call it, is executed concurrently, yeah? Asynchronously, from the perspective of the current process. But the point is that an asynchronous function, or any promise, can be awaited. And when you call await, you are suspending the current coroutine until the promise is completed. Yeah? So I hope you all understand what's going on in here. I call this function verify user, which calls verify user and get roles. Since each of them is awaited, I am first verifying user, so waiting 2 seconds, and then printing user verified. Then I get roles, so I wait another 2 seconds, and I print getting roles. So again, 2 seconds, user verified. 2 seconds, getting roles. Without await, I could not await. I cannot not await because one depends on another. But if one wouldn't depend on another, I could execute them concurrently. Right now, those two are not actual user info and user role and roles info. Those are promises of user info and promise of roles info. But right now, they will be executed at the same time. At the same time, more or less, we have user verified and getting roles printed. And of course, the Kotlin analog of that is, async await block. So let's talk about Kotlin coroutines, and I will get back to different implementations of coroutines in general. I want to start with something that should be obvious, but apparently it is not, which is that suspend functions are not coroutines. Suspend functions are not coroutines. You can say that async functions in JavaScript are coroutines, but in Kotlin, a suspend function is not a coroutine. Suspend function, I could even make a definition. Suspend function is a function that can suspend a coroutine. Okay, this means a suspend function must be executed on a coroutine. Okay, but it is not a coroutine by itself. We create coroutines with coroutine builders, so run blocking, async, and launch. Those are coroutine builders. We also create coroutines with coroutine scope functions. So coroutine scope, supervisor scope, with context, and with timeout. And there are a bunch of other coroutine scope functions and coroutine builders. Those are very important group of functions that we should know when we want to use Kotlin coroutines. They create coroutines. Suspend functions must be executed on a coroutines. Of course, it is not sometimes it is not so clear, because when you add a suspend modifier in front of the main function, in front of the main function, just like when you use a suspend modifier in front of a function in a Spring controller, such a function will be started in a coroutine, but not because it is behavior of a suspend function by itself. It is because Kotlin seeing a suspend function, or Spring Boot seeing a suspend function, and knowing that a suspend function must be executed on a coroutine, wraps execution of this function with a coroutine. What you can observe by yourself, if you want, if you find main function. If you find the main function, what I did is I compiled Kotlin code into JVM bytecode, and then I decompiled it into Java. So now I can see how my code would look like if it were written in Java. And here you can see my the actual main function. You can see it's the standard main function with arguments, and you can see it wraps our suspend main function with this run suspend, which is a function that starts a coroutine. Okay, so this is why some suspend functions will be started by a coroutine, but this is not a trait of suspend functions in general. This is a support from some frameworks, and in this case it's a compiler, but you see the point. So this function will be started in a coroutine, and we will be using this coroutine. So I want to say a bit about different implementations of coroutines, because different languages implement coroutines in different ways, and I know 3 most popular implementations. So of course I believe the most popular one, maybe not, but the one that I get to know well first is the implementation used by JavaScript, which wraps, I mean, when you define an async function in JavaScript, it returns a promise. Okay, it's a JavaScript, not a TypeScript. But if it were TypeScript, you could see, you could see that this function actually returns a promise. So in this style, our function is asynchronous by default. So starts a coroutine by default, and the result object stores the state of our coroutine. What I mean by that? Let's say that I use await in here. When our coroutine, this function, is suspended because it waits for the getRoll results, inside the promise you could find the state of the coroutine, so where you stopped, but you could also find all the local variables. So things like user info need to be captured. They need to be captured, and they need to be alive for as long as this is alive. This is something that we got used to, because it's quite a standard to us that when you have some lambda expression or function in general, and then you call something else, then the state that was captured, that was defined before, that waits for its execution, is stored somewhere. And in the case of JavaScript, it is stored inside the promise. What's the problem with this implementation? The problem is that it's not very cheap, because every async function starts a coroutine. So we are starting plenty of them, and in many implementations of JavaScript we are starting them and awaiting them nearly always. And the second thing is that we are making everything asynchronous, even if we don't need it. Kotlin chose a different style, even though they considered doing a similar style as this one. They chose a different style, a style which is much cheaper and synchronized by default. So Kotlin chose continuation passing style. I will actually use this show Kotlin bytecode as well. The idea is that when you suspend the coroutine, you need to have a place where you are storing the local variable state, so that you can resume this coroutine in the future. And in JavaScript it was the promise that kept it. In Kotlin, this state is kept in the lightweight objects called continuations. If you take a look at absolutely any suspend function like this fetch A or fetch B, you will see that they have additional parameter which is of type continuation. This continuation is object that is a lightweight object that stores the state of local variables, as well as it stores the place where you stopped. I will show that to you. So I prepared this really small main function, which actually I don't need this thread, I can get rid of that for simplicity. I show this really simple main function which calls some suspend function, and this suspend function suspends coroutine. Yeah, so it does what a suspend function can do. This is what is typically done by libraries. So we very rarely use suspend coroutine ourselves, because it is typically done by libraries under the hood. But if you would check out what is, you know, a library like retrofit or I don't know, Room doing, you would find most likely a suspend cancelable coroutine under the hood, which is a modern alternative to suspend coroutine. And so when you suspend a coroutine, you receive the continuation object. If I would never use it, then my coroutine would be suspended forever. Yeah? The suspended coroutine, I never resumed it, so my program is still running. I don't see after. What I'm doing here makes little sense. I'm resuming it before even suspending it. It will work, so it will print me the result. But the truth is it's not really suspended, because I started the process of suspending, but before really suspended, I said to immediately resume. Nevertheless, it lets me debug my code and see what is inside continuation. And you can see that the continuation object that I captured here, which is more or less, it's actually wrapped continuation object that is passed from main to C. This continuation object includes inside its delegate values DEF, yeah, 456, and it also includes completion, which is a reference to the function that called this function, that includes 1, 2, 3, and ABC. So it includes everything that is needed to resume our coroutine. It's keeping references to the local state. Thanks to that, I can store this continuation somewhere, waiting for some data, for response from database, from response from API, or for anything else. I can store this continuation somewhere. And when I resume it, I will be able to jump into where I finished. It also includes label, which marks which suspension point is that. If right now the label is 1, but if I would have, let's say, a couple of suspend coroutine, and I would debug on the last one. So here is state 0, here is state 1, here is state 2, and so here should be state 4, I believe. 3. 0, 1, 2, 3. Oh, sorry. 0, 1, 2, 3. So you see, this includes the state where I stopped. Now, people hearing that there is some object that is storing our local state think that it must be expensive. What if I would have some, I don't know, big file reference? Would it be expensive to keep this alive? And the answer is no, it wouldn't. I mean, creating this continuation is actually super cheap, because we are not creating new references to we are not copying those local state. We are only creating new reference to this local state. Wait a second, I need to start charging my tablet. We are only creating new references to our local state. So it's like the variable d is a pointer that points to the point in memory where there is a string def. Inside continuation, we make another pointer, another reference to exactly the same object. What makes continuation creation really cheap? It's actually, people think it must be expensive, but it is way cheaper than Project Loom. I mean, it depends what you compare, but the coroutine weight is way smaller than a virtual thread weight. It is also way cheaper than Promise. Promise needs to store those things inside it anyway. But thanks to the compiler support, Kotlin Coroutines do that very, very cheaply. What is quite amazing. Okay, sorry. I see myself again. So this is a coroutine. This is how this is my short description of how coroutines work. If you are interested in the topic, we might dive a bit deeper into how it is implemented, because you can see this state machine that is an optimization of and that is an implementation of the coroutine. What is quite interesting how it is implemented technically, but not very useful. You have everything that is needed already, and some details are present in the book. However, if you are willing to learn about that, let me know, and I can either make it now or make it a part of another live. I also would like to touch the topic of virtual threads, which is another form of an implementation. So some languages, especially Java with Project Loom, but also I believe Go, implemented coroutines as a form of a virtual thread. So an abstraction that pretends to be a thread, but is suspendable like a coroutine. So the virtual threads in Java behave like a regular thread, but when you block them, you are actually suspending them, what makes them way lighter than real threads. What is a nice implementation for interoperability, or maybe for reusing old code, for reusing legacy libraries and frameworks and projects, yeah? Because in the past we were blocking threads in Java, so right now we might introduce Project Loom, and nearly for free we have our threads way cheaper. But this abstraction of a thread is also limiting on different ways. Yeah. So like threads do not return values by nature. Yeah. So in Kotlin Coroutines, you can when you resume, let's say I resume with some value, this value is returned from the suspension point, which is extremely useful, because very often we suspend because we await for some value. Yeah? We suspend because we await for some request response, or for some database result. What is an extremely helpful abstraction. This can be implemented on top of virtual threads, but with other tools that implement synchronization mechanisms. And this is not the same. This is way weightier. Okay, it's the Kotlin coroutines are give much more possibilities. I mean, the continuation passing style in general gives more possibilities. Also, threads needs to have some abstraction that are typical to threads. Yeah, state. I mean, coroutines also have states, but it's a typical to coroutines, not typical to threads. Threads must have names, threads must have many different things that a coroutine just do not need to have, what makes them lightweight. Oh, it is also important that to know, or actually I will add it in the next section. Okay, I will take a look at your questions right now. Maybe I have something to answer. No? How long will it go? I'm planning it for an hour, but well, we'll see. I am kind of a person who talks too much. So when we know what coroutine as a concept is in general, we can say a bit about what is specific to Kotlin. So what Kotlin offers us specifically. And there are some features that are, they can be found in different implementations of coroutines, but I find them quite, I would say they are quite specific to Kotlin in a way. In a way they are implemented. So the most important Kotlin coroutines features that go way beyond the definition of what a coroutine is. Okay. So the first thing that I just added to my list is the dispatchers, because I want to tell you that coroutines by their nature might run run on a single thread. I mean, by their nature do not change threads, okay? So if I would check out what the thread is, current thread name, you would see that here the current thread is main, because I started this program on the main thread, but here the thread is thread 0. Why is it thread 0? Why is it thread 0? It is because this coroutine, I mean the coroutine that started main, was resumed by thread named thread 0. This is the default name of the thread I created here. So when I call resume, I execute my coroutine until the end. This is the same behavior that you would have in Lisp or generators in Python, if it is possible on Python. I'm not sure about that, but this is the same behavior, because when you call resume, you are executing the rest of the coroutine. So this should be executed by this continuation. Of course, this is extraordinary situation for the real life applications. Why? Because we have such a situation only if we have no dispatcher or when we have dispatchers unconfined. This is dispatchers unconfined. A lack of dispatcher. This situation is extremely rare in real-life applications because most coroutine builders set some dispatcher. So if I would use run blocking, it would define a dispatcher that makes my code run on the main thread always. Okay. I mean, this coroutine run on the main thread always. If I would use dispatchers default, my coroutine would be executed on some workers. Yeah, in this case it is worker 2. This is the same worker, but it doesn't have to be. If I would make some of my workers busy, maybe let's do something stupid like thread sleep on global scope. Global scope uses dispatchers default by default. So I'm making a bunch of default dispatchers busy, and then you can see the first part is executed on the thread named worker1, and the second one on the thread named worker4, which shows us that a coroutine might have one part executed by one thread, another part executed by another thread. Of course, what decides at what thread a coroutine is executed is dispatcher. Dispatcher is a kind of context that decide on which thread or pool of threads a coroutine should be executed. And it is, it's an extremely powerful feature. I have a whole chapter about it. It's one of the best of my chapters, and I highly recommend that, because what Kotlin creators have done it for the thread reusability is absolutely amazing. The dispatchers default and IO, they reuse the same thread but have separate limits, so they never, they never block each other, but at the same time they there is a created minimal number of threads. It is absolutely beautiful what was done with dispatchers. It's one of my favorite parts of Kotlin Coroutines, and one of my favorite sections to explain on my workshops. The second thing that Kotlin creators have done pretty well is, or maybe I will change the order, and I will talk about structured concurrency. So structured concurrency is a really big term, the term we probably do not have time to discuss in detail in here. But the general idea is that when you create a coroutine inside a coroutine, either with launch or coroutine context, coroutine scope function, this coroutine inside coroutine is a children of the outer coroutine, and these children, this parent-child relationship give us a very important behaviors. It gives us proper cancellation, which is extremely important on Android. That when you cancel the parent coroutine, all the children coroutines are cancelled too. The exception handling, this is another thing I wanted to talk. Awaiting and the context passing. All those mechanisms are extremely important, and they would require quite a bit of time to explain them. But I will just say that coroutine started inside a coroutine as a children of the outer coroutine, takes its context, so it also reuses the same dispatcher by default. Of course, it can change the dispatcher by setting a different one, but by default it is reusing the same dispatcher. It is also inheriting other kinds of context, which can be really useful. Like we can use a context which identifies a request on a backend calls. We can pass a context that defines default exception handling on Android for the standard ways to handle exceptions. It can be extremely useful. But two other things that are connected to structured concurrency and are pretty powerful Kotlin features are awaiting and cancellation. So a few words about awaiting. So as I mentioned in Kotlin Coroutines, suspend functions are synchronized by default. So if I call a suspend function, by default, I am just entering this function, waiting 4 seconds, printing A, returning A, and only then I start calling another function, waiting 2 seconds, printing B, etc. So things are synchronized by default. which is cheap, which is also actually I find it quite convenient. We do want to execute some things asynchronously. Then we can just use async await. But I believe it is much more common to rather call things synchronously. So the synchronous behavior with optional asynchronicity at any point, I think it is actually a very, very good choice. It is also good to know that every coroutine, when you launch some coroutine, every coroutine execution can be awaited. Every coroutine builder returns a job, both launch and async return a job, and this job can be used to await this function completion. So imagine that you have two functions, so maybe one function start process A. I'm not very creative, but I already have A and B, so maybe C, which will use some coroutine scope to launch a coroutine. Scope launch coroutine. I think this is something that many Android developers can relate to. You know, in view models we have plenty of functions that start processes. By the way, I'm mentioning Android pretty often, but I work much more with backend right now. I actually work with both of them, but I have in last years I have way more experience with backend. It's just that Android, it actually is quite visible that many Kotlin features were implemented with Android and actually frontend in general in mind. This cancellation is something that is barely useful on backend. I mean, there are advantages of having cancellation or awaiting, but those things are especially useful on Android. So when you start those two processes, you do not know if D will be printed after or before C. When I started right now, it's more likely I will see CD, but if I will make my processor busy, how can I make my processor busy? Let's make a ton of coroutines, each doing something stupid. If I would make my processor busy, then I could find situations where D is executed before C. Oh my, I blocked my threads for too long. 100, I have 8 threads on dispatcher's default. Yeah, it's oh no, I know what's the problem. I will do something like that. Scope, context, job, children, await, for each. Normally it is something that is done by structured concurrency, and it is actually something I could mention. Oh, I need it in a blocking. Okay, ugly, but will do. So if I start my program enough times, I should have situations where, oh yes, D is executed before C. Why? Because both functions start different coroutine. You know, there is a race. This coroutine is started slightly earlier, but well, they are executed concurrently at the same time. D might be printed before C. And we have quite nice mechanisms to synchronize that, and the most correct one is to collect jobs. So if there is one process you want to await, the typical solution is something like that. Maybe it should be called C process job. We set it here, and in here we know it's already started because we started the process. I mean, if we don't, then this process will wait forever because it awaits for the C completion. Nevertheless, this is the way to make one process await for another. Okay, it's not the only. I could also do the opposite. It wouldn't be safe because this could not be set before the. So no, we must start with the C process, then the process. Of course, it's not the only trick. We can use a scope to get children and await other processes in different ways. There are plenty of ways to await coroutines. You can also use completable deferred or a standalone job. So one process can create a standalone job or a completable deferred for a, let's say, unit. Okay, and one process once finished my completed, and another process might await its completion, either join or await. Should be the same. So we have plenty of powerful mechanisms to await processes. By the way, I recently had helped with a problem where the team needed to make one coroutine await until the second coroutine sets up a listener on mutable state flow. Let's use it with something, doesn't really matter what. And my simple solution was to, when we await on that, to start with on start completion complete. Yeah, there's some completion awaits, then we do what we need to do. Collect. Then we do what we need to do, and the other process before sending something to this state, before setting some value, either something like that or emit, await the completion. It should be something like state flow started. Yeah, nice trick. I hope you see the point. Of course, there are other ways to solve that. You can set up reply here, but not always. We want to have our mutable state flow. It was actually mutable shared flow, not a state flow. State flow has reply of 1, so mutable shared flow. Okay, but getting back to the topic and to questions, I will just finish the last feature, which is quite powerful and typical to Kotlin Coroutines, is cancellation and exception handling. By default, when we keep structured concurrency, the coroutines and processes that we start on our coroutines are children of the coroutines that started them. So when we cancel the parent coroutine, all the children are also cancelled, which is extremely powerful, especially for Android, where you pretty often when you open some view, you start a bunch of processes, but then you close this view and you want them all cancelled. Okay. In the past, we did it to collect all those processes to cancel them. Kotlin does that out of the box for us. But it is also useful in backend because you know, like in this fetch example, yeah. Let's say that we fetch A and fetch B, and B has exception. So what should happen to fetch A? And the answer is that fetch A should be cancelled. And thanks to this coroutine scope, it will be cancelled, which is what is not true in most other Kotlin Coroutines implementation, like on JavaScript, which is quite a nice feature for our memory management, for avoiding memory leaks, for using our resources efficiently. Exception handling is also quite powerful, with different modes of working. It needs to be understood because it's not so easy, but it is quite powerful. And with this, I have some questions on chat, so I will check them out right now. Hello from Colombia, hello from Poland. Is there any workaround for reified generics on class level? I am not sure what case do we mean in here, generic for what. The reified parameter allows you to use exact type when you inline a value. I'm not sure about that, but I have some memory that with inline classes they might be supported, the reified class type parameters, but I'm not sure if it is going ever to happen. I don't know any workaround for that, but if I see a concrete use case, I might help with that. Of course, if you cannot use a reified type, you need to pass a class reference or a type reference, which you create with type of. So you need to create an additional. It actually might be an answer because what you want. I understand. There was a question. What is the workaround for a class reified class parameter? So of course it is not possible, but the question is why do you need that? And typically it is a substitution of a class with a class reference. So class or Java class, something like that. And if you need a if you need or a type reference, it could be depending on what do you need. Type references gives us more k-type. Okay, so if you I believe that could be replaced. I mean, if what you want is the nice syntax for creating such a class instance, I think you could consider using fake class constructor, which can be reified because can be inline, reified, and here you can create my class of t with class reference. So, and if it needs to be any, if I set such a bound for my class. So that seems like the answer to the question. Normally on workshops I can have conversation and people can show me some code or ask me what do they want exactly, but here we have latency and it might be a problem with that. Thank you, Alexander. We currently I'm not having any way to win those books, but maybe I will be able to start giving some of them on some conferences once I print them by myself. Because currently those books are printed by Amazon, KDP, which is very convenient because they print it locally around the world and send it from local printing place. But I'm not happy about the quality. I think quality comparing to other books. I mean, comparing to US books is okay, is nice. But I think the quality in Europe of books is higher. I hope I'm not making anyone angry right now, but I'm used to a higher quality of the paper and of those covers, you know. I like paper which is actually this paper is quite okay, but I use a better one. I like a cover which is a soft touch, which is, you know, much more resilient. And to achieve that, I want to print those books on my local printing place. And I'm not sure if I'm going to sell them, because it's extremely hard to, you know, sell books around the world from Poland. I mean, it's even a problem for European Union, but sending to faraway countries, it's extremely hard. So I might not be able to offer them so widely, but at least I might have some books for conferences, or maybe for those who are willing to buy a bundle, like conference organizers or other I don't know, companies or selling places. We'll see. I must say those books are alive around the world. The biggest surprise for me is Korea, which is in South Korea. They first translated effective Kotlin, then now they are translated Kotlin Essentials and Functional Kotlin. I don't know why they missed coroutines, but they are selling like crazy. I am receiving information from them, and they are selling really big numbers. Also, at least some of those books are translated to at least a few countries, a few languages already. Run blocking says this function should not be used from a coroutine. Yes, that's a good point. So, I mean, run blocking is a strange function. I will explain to you what it does. Run blocking is a function that starts a coroutine and blocks the current thread until this coroutine completes. This blocks is not a very precise word, because it actually it is blocking it, but it is also using it. It is also using it to execute its body. So it is using this thread and the current thread for the dispatcher. So run blocking is very specific. It is blocking a thread, what means that it should definitely not be used from any coroutine, because in coroutines we do not like threads blocking. We are managing very precisely our threads usage on Kotlin Coroutines. So run blocking should be start on the starts of our system, so inside a main. However, we rarely do it right now. We generally tend to prefer suspend function, and if we need to make a scope, then coroutine scope. So this usage is still valid, but well, we have a better alternative. The second place where we might use it is some test suite, or I don't know, test class, something test, okay, where we might define some test function and wrap it with run blocking. So this is, again, this is possible, but not a preferable option because it's generally considered a preferable nowadays to use run test in here. So we rarely use run blocking inside our production code. We only use it when we explicitly want to await a complete when we explicitly want to block the current thread until some process is finished, which should be rare, but might sometimes happen. I remember having this situation where I had some function, let's say a function that started a bunch of coroutines on some scope. I should have a scope. No, I don't. Where's my scope? I lost my scope. Okay, it doesn't matter. I started on some scope, and quite a number of functions. And the problem was that such function completed immediately. What is typically what we want to achieve, but in these cases this is not what we wanted to achieve because it was measured. So there was a tool that was measuring execution time of this function. So this function executing immediately wouldn't be a good solution. So when you explicitly need to block threads, then run blocking is a good choice. If you still want to use an outer scope, then you can do something like run blocking here, collect our jobs, either one or multiple jobs, and add them all, or make some map into jobs, and then for each join, either join if you have one of them, or for each join if you have multiple jobs here. Default use same pool. Okay, this is what is this optimization? Okay, it's over an hour, but I will stay with you because we have a couple of interesting questions, or maybe not. I will make a dedicated episode about dispatchers because this is an amazing topic. But if we want to cover it well, then we should spend some time. Select. I'm not sure what does this question refers to. Select is a interesting function which is used to await the completion of the first out of a few async processes, or or for the first value or empty space in a channel. By the way, I added to the second edition a chapter about select as well. Select is not used too often in our code. However, it is used by some tools. For instance, functions like race off, which already has a few implementation for coroutine races. Relationship between coroutine, continuation, context, and element. This is actually quite connected to the chapter. But this also deserves a separate episode, so I will just make a very brief explanation. So context in Kotlin Coroutines is a holder of data, like a list, or it's more like a set or a map, yeah? Technically speaking, Kotlin Coroutines creators could not define context and use set instead. Okay? this would work perfectly fine. I believe why they used defined context by themselves is the convenience of its use. Yeah. So context, let's use coroutine name, is designed in the following way. Every element of a context, you know, this coroutine name is a specific kind of a coroutine context element, yeah, and coroutine context element is a coroutine context by itself. That's actually quite intuitive if you think about that. You know, this is a class which is a very specific element, but you can also see it as a collection. As a element of a collection. What collection? A collection that includes a single element. Yes, this is how context works. So this coroutine name is of course of type coroutine name, but it is also coroutine context element, which is also coroutine context. So you know, this element is a set by itself. However, if you add two contexts together, so coroutine name and let's say a job, if you add them together, you have another context, which is of course a context as well. Yeah. So if I had another element, bam, I have another group, but this time a group of two elements. And out of a coroutine context, I can get a specific context by a key. Each kind of element is identified by a specific key. This key is typically a companion object of this element. So to identify a coroutine name, I use a coroutine name key. So inside context 1, I have coroutine name. Inside context 2, I do not have it. Inside context 3, I have it again. The same can be done for a job, but for a job, inside the first one there will be null, so nothing. Inside the second and third, I will have a coroutine name. Okay, let's see if why does it not work? 1, 2, 3, 4. I must have copied some additional thing. It doesn't matter. Here I have now all the other values have something. I can also have an empty coroutine context. So empty coroutine context is an object, and adding that to something does not change this something. I can add context to a context. It's like in a map. So a new element with the same key replaces the previous one. So right now I only have coroutine name B, yes, because the new element replaces the previous one. This is everything. It's just a form of a collection. And this collection is a basic way to store information in Kotlin Coroutines and pass them around. Yeah, so coroutines keep their state inside a context. Coroutines keep their state inside their jobs. Job is a form of a context, so they keep their state inside a context. When you call a suspend function, as you know already, suspend function has continuation, and continuation has a reference to a context. Thanks to that, when you call a suspend function, this suspend function has reference to the context of the coroutine that called it. Yes, so this context is passed around. I will even tell you more. Inside absolutely any suspend function, you can read a current coroutine context, either with property coroutine context or current coroutine context. They give the same value. Yeah, they give the same value. I hope you see the point. The two options are for convenience, because coroutine context is in suspend lambda expression is often overridden by scope property of the same name. So this is actually quite useful. So when you read this coroutine context, you are actually reading coroutine context from continuation reference, which is passed implicitly, and this is a part of structured concurrency. this context is passed from suspend function to suspend function. Every new coroutine, like when I use coroutine scope, I start a new coroutine, but this coroutine will be a children of a coroutine that called A and will inherit its context. Why? Because thanks to the fact that this context is passed through continuation. Confitura, call for papers. Okay, good idea. I will fill it maybe with some new interesting presentations. The mechanism on suspending. I believe this is the last question for today. There is also a comment about coroutines and threads. Coroutines are certainly way lighter than regular threads. In most use cases, then they seem to be lighter. Yeah, there are good reasons for that. So I believe it can be stated with some sureness, even though of course some Loom fans will not like it, but I believe coroutines can be considered lighter than virtual threads as well. Virtual threads might in some cases be faster because they have, but it's also not certain. They have native support, but on the other hand, coroutines have compiler support. Yeah, but in terms of memory, I'm pretty sure Kotlin Coroutines could be considered lighter. So the webcam is suspended. Yes, this is a problem of this webcam. Not this one. I have no idea why, but I restarted my computer formatted my computer about a week ago, and since then I have this strange problem that the camera is sometimes freezing. Okay, the last question was about this label that has changed. So I will answer that pretty quickly because it is connected to the topic of today's live. Or maybe I will just do something simple. So how Kotlin coroutines are implemented very, very quickly. Whenever you call a suspend function, you are generating a suspension point. It's like you cannot suspend at any point. The println function is a regular function, so it cannot suspend. Yeah. The same, all non-suspend functions or executions cannot suspend, so you cannot suspend in here. But suspend functions can suspend. So whenever there is a suspension point, you are generating a place where a suspension can happen and resuming can happen. And when you resume a certain function execution, you need to jump to where you stopped. And there are only a few places where you can jump, and those are suspension points. So this function can be started from the beginning, which is a label 0. It can be suspended and resumed straight after the execution of delay, which is a state 1, straight after the execution of the second delay, which is a state 2, straight after the execution of the next one, state 3, and straight after the execution of the fourth one, which is 4. And this label for each continuation identifies where this function should be resumed. Of course, each suspend function creates its continuation, which is actually the highest cost of using Kotlin Coroutines. Not copying the state because this is cheap, but creating a new class. Yeah, each suspend function call needs to create a very lightweight but still a class, and creating a class is some cost. So this is what is a true cost of Kotlin Coroutines, creating a very lightweight class wherever you call a suspend function. It is something. It is still way cheaper than let's say React or operating on a flow where each lambda expression is also creating a class, and not only lambda expression but also wrapper call execution. So they are way heavier in this regard. So comparing to most nowadays solutions, Kotlin Coroutines are extremely cheap. Getting back to this topic, if this function were called inside another suspend function, this suspend function has its continuation and its labels. So it also has label 0 here, label 1 straight after this first A execution, label 2 straight after the second one, etc. etc. A fun fact is that if you do something like that, state 3 is after this function execution, there is state 3. It doesn't matter which loop is that, because when you are looping, you are jumping inside the same function. Yeah, so you are just repeating the same places of code. Yeah, the thing that changes is a local state of the variable that counts how many times you repeated already. But I have planned to make a dedicated episode about how coroutines work under the hood, where I will analyze that. This is one of the episodes I have planned to do, but I'm not so sure if people are interested about that. It is really interesting, but it is also not very useful. So please let me know if you are interested in that. And with 1 hour 23 minutes, I think it is time to finish this live. Thank you for today. If you like my explanation style, I will remind you that you can have a workshop for your company. All my workshops are on kt.academy. I am an active developer. That's why I'm a bit tired right now, because I spent whole day working. But it doesn't stop me for taking days off and conducting workshops more or less once a month. I have those workshops really well prepared. I conducted more than 100 workshops already about Kotlin. And those that I'm living in here, especially Kotlin for developers and Kotlin Coroutines, and this one is a different variant of this one, are extremely well prepared and battle tested, field tested. I also might recommend my new workshop, testing in Kotlin, which is a newer one, but I'm really proud about it. I think it's a nice one. I also have a workshop about Flow, which I'm currently not displaying, but if you are interested about Kotlin Coroutines but concentrating on Flow, we can do that as well. One last thing I wanted to add at the beginning, and I forgot about that, is that I'm trying to make this format audio friendly, so that you can play it in background while doing other things around your while doing other things. What I hope you will appreciate. I actually like listening to podcasts when I doing house chores or walking my dog, so I wanted to keep this audio friendly as well. However, I'm also showing some things, so it will be visual as well. Okay, so thank you everyone. I hope you liked it, and I will announce another one hopefully soon. And for now, have a happy Kotlin, and I hope it will help you at least a bit with your own projects and your own usage of Kotlin Coroutines. See you at the next occasion, or on a